Okay, this is Toby, and I'm going to continue trying to debug this mystery. We want to solve the mystery of why this guy, this deep zoom debugger, when we zoom in here, beyond a certain zoom level, in this case it's zoom level 206, um, the screen kind of starts blanking. So we came from, well, I kind of changed the code to a state where um, it's kind of more broken than before. But let me actually take a look at my code right now. I want to see whether, like, when was the last time I committed this code? It was April 30th, which is okay. Yesterday, I think. And I'm gonna look at the diff. What did I do today? Yes, this looks like everything I've done today. Some logs. I deleted a bunch of comments. Yes. So if I were to revert everything to before I did anything today, that would be cool. So okay. So I'm not totally worried about not being able to get back the sort of previous working state for some definition of working. Okay, so this problem is particularly tricky to debug, and I took a little nap, but while I was taking a little nap, I was thinking about what to do to diagnose this problem. I have two ideas. One is to give myself better debugging visualization, um, and there's a principle that I truly believe, and which is that whenever programming is hard, it's because you're not seeing what you're doing. And that's part of the reason why I'm building this debugger in the first place, to allow developers to see better what their program is doing. And with graphical programs, programs that have a graphics component to it, um, it usually helps the developer to build something for themselves that can allow them to see more clearly what's going on. And this scenario where in this scenario, I have a situation where I have a very the, the deep zooming interface is there's a very, well, it's not a large canvas in reality, but there's a very large world in a sense, because initially you're looking at this box, but if you zoom in more, wow, there's these much more details in here. And if you zoom in more, and you realize that there's actually much more details in here, and then you zoom in over here in this little box, you realize there's even more details in there. So if you were to render all of the details out to a, let's say, a sheet of paper, uh, you might need a very large sheet of paper in order to be able to see all of the details within it in the physical medium. Um, and I guess because of that, it might be difficult to visualize what's going on, and when all you're doing is staring at numbers, like a viewport has a left, oops, has a left and a top coordinate and a zoom coordinate. Um, you're you're looking at these numbers, like, I don't know, you're looking at these numbers and you're trying to imagine in your head, translate that into an image in your mind. That's actually quite difficult to do. There's some the people who are really good at doing this kind of stuff, obviously are very good at doing that. Sort of imagine pictures in their head based on like translate things into picture images. In particular, I believe Benoit Mandelbrot is one of those kinds of people. Um, but instead of doing that, if you're not quite as good at doing all that in your head, what you could actually do is build a tool to help you visualize. And I was thinking one thing I could do is make a little mini map, like a world map, and many video games have this. You make a mini map in addition to the main view, and you have a box within the mini map, and perhaps you have like a rough sketch of the objects in the world. I'm gonna do the rough sketch maybe in gray, so you have, I don't know, I don't know what the rough sketch might look like, but then you have a different box to represent the current viewport that you're looking at. So the outer box is the entire world, the coordinate of the entire world. All of the objects in the world have to live within the outer box, and then this inner green box is your current viewport now. That's the view of what the section, the subsection of the entire world that you're looking at right now. And I thought that perhaps if I had a picture like this, that could help me more to solve this problem. However, I also realized that at some point, this box could get so small that it doesn't tell me a whole lot anymore. Um, because of the deep zoom nature of this thing. And so it's not that this wouldn't help, but I'm not totally sure that it would. Okay, it would end up being fruitful. So, but there's still one avenue that I'm willing to explore. Another thought is perhaps instead of having to deal with this large number issue, we do a sort of scaling, a sort of normalization at each level. At the time we render something, to scale the thing into a more reasonable frame, uh, so that we can sort of reason about it. Let me try to explain what I mean. So, for example, if actually I think I'm going to undo back to last good state. Let's go back to last good state. Good state, good state. State farm. Is that the last good state? Okay, I think that's okay. Alright, I think this might be last good state, maybe ish. Going to try it. The sun is a little bright in my face, even though I am behind curtains. Okay. Alright, so I reverted back to my last good state, and the UI currently works like this. This is the main function call. We zoom into it, see the code within the main function. We zoom into the fib function call, and then we see this implementation of the Fibonacci function. We zoom in more, etc., etc., etc. And let's do this. Let's add, I think I might already be doing this, but I'm not sure. No, I'm not already doing this. So I have these logs that are being printed here. This canvas coordinate is printed at the top level render function. Here, I actually care less about this one, and instead I want to look at the one that was passed into here. I think I have done this at one point, so I'm just redoing this. Okay, and then I'm gonna also I'm gonna print out my box. Yeah, let's just do that. And okay, this output is slightly hard to read, but let's try. Okay, so let's start with when the view looks like this. I'm gonna zoom in slightly, or maybe just move it slightly so that it renders again. Okay, so render, we are rendering the main box, and my box here is this. I render it again. Okay, and my box is here. So the box is the box being the box that you see on the screen. So this one. So this box, the bounding box is this. So x, y, that should be top left corner. X, y is 168 something and 206 something. That's what that says. And the width and height are both about 840 pixels. So 840 and 840 here. Okay, if we zoom in more, oh, let me get out of the drawing mode. Okay, if I zoom in more and I zoom into this fib. Let's see, did it zoom into the fib? Yeah, it did. Okay, so at this point, the main box is actually, the main box is kind of way bigger than our viewport, right? So our viewport is like, our viewport is always, let me try to visualize this, so the main box is, so our viewport is always, so this is our viewport, and our viewport is always starting from the coordinate 0, 0, and the width is 1200 and the height is 1200. Okay, that's always our viewport, but the box that contains that represents the call to the main function at this point starts at negative 2561, and if this is, if this is 0 in the x direction, right? This is the x direction. This is the y direction. So if this is 1200, then negative 2000 something. What is it? Negative 2561 is gonna be like, maybe 1000 is about from here to here. So 1000, 2000, so 1000, 2000, 2500. So this line is 2561 maybe ish, and then y is negative 142. Okay, so this is 1200. So 100 is maybe like that one. So negative something 142 maybe here. So this is our coordinate, the top left corner of the box representing main, I reckon. So x is 2561 and 142. And then what is the width and height of the main box? Well, both of them are 4512, 4,000 something. So 4512, this is 25 something. There's another 2,000, so it goes from here to around here. And then that kind of goes out of view. I cannot write. So the main box is this bluish box here, but what you get to see is only this subslice. This is the viewport. Okay. And what we're seeing right now is just the part that says fib something. Yeah, it's like just this. We were looking at just this subsection. It kind of looked like this, and then let me get less input. Okay, and then it does the same thing for this fib7 function call. This fib7 function call has its own box, which is it starts at coordinate 232, 245 within the canvas coordinate. So 232, 245 is probably, I don't know, around here. Let me look at the picture. Yeah, it's around here of the viewport. Around here, and then the width and the height of this box is, the width is 1000 and the height of the box is 248. So 248 is like that, and width is 1000. It extends slightly outside the box, and that is what we see. See, this box is slightly cropped. It probably ends around here. Yeah. So that's what's going on with this one. Let's drill in more and see what the boxes look like. Okay, so now at this point, we drill in more, drill into the Fibonacci one. Okay, so this is fib equals 6 for this box, and fib equals 5 for this box. And this now it has the, well, at the viewport level we're looking at right now, it's the screen coordinate is 45 and 197. Both of them on screen, and that's why we can see them. But its parent box has a much larger width and height now because we zoomed in so much. The parent's parent has an even bigger height and width. And because these numbers are getting so big, I suspect there's this numeric precision issue going on. So if we zoom in even more, well, the boxes here we're looking at, this fib3 and this fib4, have coordinates that are on screen. The parent and the parent's parent's parent and the parent's 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 parent. So original parent, it's the height and width is so large. Let me see if I zoom in more. Okay, so this, let me zoom in here. Okay, this is where it breaks, and the height and width of the fib3 box, or the x coordinate, is completely out. Oh, interesting. It's negative, even though it should be on screen. So that could actually be because the number wrapped around. Because it's not supposed to be anywhere near negative. Well, I mean, for the one that's supposedly on screen, because if I zoom out just slightly so we can see stuff again, for the things we see, they are actually on screen, like this fib n equals 3. Well, the fib n equals 3 I actually don't see on screen. I guess now I see it. This one is on screen, and the fib n equals 4, that's on screen right now. If I zoom in, now I can't see anything, but the and this x coordinate is negative now. Yeah. Okay. So it shouldn't go out by that much. Yeah, everything. The x coordinate of the things that ought to be on screen, which is this 4 and 5, their x's should, their coordinates at least should be on screen, and at the moment they're not on screen. And I'm not sure why. I mean, those calculations came out of the fitbox algorithm. I guess I can look at that algorithm, try to get some clues about why. I do think it's important to, before attempting solutions, to try to actually understand the site of the actual problem occurring. So at some point there must be some like addition and subtraction going on. So this is the addition here. The x and y coordinates are at the end determined by these offsets here. There's an offset x and then a y offset. Yeah. Okay. Let me think. I can detect the problem. Maybe if the number, because this offset is supposed to keep increasing as we add to it. The offset x, that's just the passed-in offset, so there's no math being done to the offset.x. But the y offset, that is the one that gets increased with every iteration of this loop. The y offset gets increased, and I suspect that at one point it flipped because it overflowed the number, maybe. However, this value is not so big. Well, yeah, it was positive, and maybe then it became negative after adding. So okay. I'm gonna try to detect this by doing this. So I'm gonna say previous y offset is y offset if previous y offset is positive and y offset is negative, then that's a problem. Throw nil error. Number wrapped around. And I'll print out both the previous offset. Now let me use the template string so this looks slightly nicer. I'll print out all of the relevant culprits. Okay, there's another place where this happens. This is for the vertical layout, box layout, and then I have another one for the horizontal, where instead of Y offset, I have X offset that I should test. Alright, let's try this and see whether it encountered the error. And if it did, that's good news, because that means our theory was right. Okay. Except that I appear to have a compiler error. Is that true? Oh, yeah, 165. Oh, yes, I totally meant X offset here. Okay. Okay, the wraparound doesn't appear to have happened. I don't see that error, curiously. So I think my theory might be wrong. Maybe. Alright, let's get into the specifics then. So I know, because I wrote the code, that this is going to be a horizontal layout. And there's a horizontal box, which will go through this path. The horizontal box contains this bit fib1 equals, and then this bit fib5, and then this bit. I have an idea. I'm gonna do the poor man's debugger trick, poor man's conditional debugger trick, I think, which is to say, well, currently these values seem to be correct. Well, these are out of range because y is too big. I think I think this fib n equals 3 is way down there, out of view. The fib, I think this one is also out of view. The ones that are in view are these. This one and this one. Okay. So yes, so this one is in view. That coordinate is in view. The width is 1000 and something. Okay, I guess I will believe that. Seems a little big, actually. And the width of this is 1000 something. Is that really true? Seems a little bit big, honestly, but okay. Um, so this is what the numbers that work look like. I know that if I drill down into fib 5, let's say fib 4, although there's multiple versions of fib 4, that makes it difficult. I'm trying to think if I can write an if statement that'll let me only conditionally print things out so that I can get more detailed into maybe I can use the level. Yeah, I have a level number now. So let me print the level. Okay, so let's see. So we're at the point right now where we don't see stuff. We don't see anything because the range is way out. I want to know how did it come to be that way. Hey, 怎么啦，多多？
Are you reading your book?
Still doing some coding. What are you doing? Are you done with your work?
I finished my book, but I have to draw and do the back cover, which is easy.
Okay, that's good to hear.
Well, I took a little break.
I see. I'm trying to solve this really hard problem right now.
Which hard problem?
This is not drawing. Remember the deep zoom Google Earth thing?
Yeah.
I'm doing a deep zoom version of a debugger for this program. Look. So first there's main is the function, the function that the program starts. The main is gonna do this print, and then it just calls this fib function, and then the fib function does stuff inside it. So you can zoom in to see what fib function does, and these things are what fib function does. You can zoom in even more. The fib function calls fib function again, and then you can zoom in more to see what fib function does again, and then you can zoom even more in. So, but the problem is if you zoom in too deep, everything blanks out, and that's wrong. So I'm trying to fix that, and it's kind of hard to fix. But yeah, I'm trying to kind of really concentrate and figure it out right now. So let's see.
Do you have a radio here, like the walkie-talkie thing?
No.
Oh.
It's not in here.
One is in the basement. I'm checking if we have both.
I see. Okay, it's interesting that this one is negative, but not negative by that much. Why are you taking my mic? I'm actually using it. I'm using the mic right now. Dude.
Then you have to do it here. Then you can see.
But then I have to, like, it's in my way when I'm typing. Let me see. So it's not negative by that much here. But if I zoom in just a little bit, this this is level 2. I printed out the level, so this I think helps. So level 2, and then fib 4 and 3 are level 3. The 5 and 4, this is also level 3. I believe it's these ones here that I'm looking at on screen. So the level 3 fib 4, there are actually 2 level 3 fib 4s. Level 3 fib 5. There's a level 3 fib 3. Okay. Alright, if I zoom in a little bit more, then I want to see what's the state of the level 3 fib 4, the first one. Okay, that's the plan. Zoom in a little bit more. Oh, it's gone. So so now I want to look back at level 3 fib 4, and its x direction is it's very negative now, whereas a moment ago, I'm just going to look at the previous one. A moment ago, it was not negative at all. Just one moment ago. So, how did it get that way? Maybe we could track the numbers that were sent to the layout function or sent to the fitbox function. Capture the input and then capture the output. It will capture the input because the fitbox function is a function. It is for a given input. It should always return the same output. It should be a pure function. It should be a pure function, I hope. And if it were, then I can capture the inputs when it worked correctly and capture its input when it doesn't work correctly, and then sort of look at the difference and also rerun the same input to maybe drill down to what went wrong and at what point it went wrong. Okay, I like that plan. How do I do it? I might need to maybe I just say if the level is 4 and the function name is fib and the parameter n is 4, then I'm gonna print out that extra output. Yeah, let's do that. Let's do that. Let's do it. Let's do it. Sorry about the incomprehensible jabber, but it's been a long day. Okay. So what I'm going to do is what I want to do is capture this input. Yeah, capture these two things: the box input and then the my box that was sent to fit box. And but I'm only going to do it if level is 3 and the function name. Do I have a function name? Yeah, fun name. I also have a stack with which I can get the parameter n. Okay. Fun name is equal to fit and stack dot parameters dot n equals 4. So I want to debug if all those things are true. Okay. And now print out all the things. So fit box for fit for, and I'll print out the outer box, my box, and B box map. And then I will cool it with the other output so that there isn't so much output. What's going on? Okay. There's still a lot of output. I'm gonna cool it with that output. I thought I saved this, but I didn't. Okay. Why didn't it trigger? I thought it would have triggered that output. Where is that? If level is 3, yeah, it's 3, and the function name is fib. Looks like function name is fib, and n is 4. Looks like n is 4. Why didn't it hit this line? No. Let me see. Did I misspell parameters again? Oh, parameters. I wrote stack, and oh, it's not stack. Stack is the no. No, this looks right. I'm gonna put parentheses around these things because maybe my order of precedence is wrong. I don't know. Why? This is surprising. I'm gonna, okay, I have an idea. I'm gonna remove the last part. It still didn't do it. If level is 3, isn't level 3 right now? Unless it didn't go here. Oh, it didn't go into, okay. It didn't go into this branch. It's probably what it is. Okay. I think that's what it is. Okay. Okay, so for this, for fib, it didn't go above. I see. Okay, but it already happened at this point. As in the bug already happened at this point. So maybe I should change my criteria to um, let me think. It's this guy. Maybe it should be level 2 and n equals 6, for which I'm printing out this n equal 5 and n equal 4. Because we already have a problem at this level. We're not even recursing down for this one. That is actually surprising, because I thought we, at the point at which it's not due to recursion. The numeric precision problem occurs not because of recursion, not because another level of recursion. Okay, anyway, let me do this. I'm going to say in level 2, that does happen a lot though. Yeah, I'm gonna do this. I'm gonna do this log when those are happening. Okay. Whew. That's what I wanted, I believe. So this is the box that's supposedly for FIP6, and we sent in these parameters, and we got these results back. And okay, I think I'm going to capture these values. Can I like just copy it? Let's store it in a global variable and copy temp1, paste. Okay, and this is our outer box, and then store the second one as a global variable, and then copy temp2, and then this is our my box. There it is. And then I'm gonna copy this map here. Oh, this kinda doesn't work. Cody. No, that totally doesn't work. I could, oh shoot. Shoot. This is a map and it doesn't, it can't serialize into JSON. But we could serialize its entries, I believe. So I can say temp3 entries, and then array from that guy. And then that I can copy that, I can serialize that into JSON. Jesus, that's a lot of output, man. Okay. Okay, so that's one where it doesn't give the right answer, or there's a problem, I should say. And then I'm gonna capture one where it actually looks fine on the screen. Okay. And sort of then I can see whether there's like some clear difference. Okay, I'm gonna serialize temp6 and then so results was that. Whew, okay, I'm gonna save this maybe. So the first one was bad result here JS. Second one is good result.js. Okay. So what can I say about these guys? Let's see. In the first case, we're going to look at first. Maybe do a split. Okay. There's actually a huge difference between even the initial coordinate that were used. I thought we were tracking. I feel like I should have been able to catch this before, because this is more of a problem of the initial bounding box that were used to draw the thing. Like this guy's width is well, a little bit, is like more than half of this guy. This is more than half of this guy. This is a little more than half of this guy. but the difference in the x and the y is enormous. Maybe that is the problem? Is the great difference in the x and the y. And that has nothing to do with this algorithm at all. So I think I'm gonna do, interesting. That's quite interesting. But that could be because of what happened previously to get to this point. Okay. Okay. We have a lead. We have a lead. So I'm gonna reiterate that. Make that painfully obvious that this is the problem. I'm only going to output the my box for FIP6 in the good case versus the bad case now. So this is the bad case. In the bad case, the box for FIP6 is that. That's exactly, yeah, that's exactly what we have. I'll go to the good case. Look, this is the good case. This is the good case. Zoom in. Bad. Good. Still good. Okay, the good case is we have this, which is, yeah, it's close-ish to this. So the good is this. But zoom in just slightly more. Okay, still good. All right, still good. Still good. This is even closer to the breaking point. Even closer to the breaking point. Zoom in just a little more. Now it breaks, and when it breaks, it's different this time. What? But the Y is enormous regardless. Zoom in just slightly more. And then now X is enormous in the negative direction. And I guess the big problem is the Y became enormous. And I guess we need to suss out what caused the Y to be so enormous. It's just a very small zoom level change to cause that. Okay, so that's good. We actually didn't need to capture that many results. The only key piece of evidence is the box. Okay, but we actually need to go back further to figure out what caused this, because we sort of need to trace backwards. To let's just print all the things. Print the my box for each I guess we do need to figure out what is the oh, I have an idea. So for FIP6 at level 2, this is what we got. But the parent of fib6 level 2 is fib7 level 1. Let's print that as well. Okay, so this is what I'm going to do. And while we're at it, let's print main as well. Okay, so level 1 fib 7, I want to see it, and also level 0, if the function name is main, I want to see that as well. And in each case, I want to print out the input, but also the output. I think we might want to just make an object to make it easier for us to copy. Data outer box, my box, and then b box map entries, which would be b array dot from b box map dot entries. Yeah. Okay. So that's the data. I wanna put that into the console. All right. Let's see what happens. All right. Okay. I actually want to update the printout. Okay. Print a helpful log message there. I think that way we can see at which level the problem began at. So, alright, this is bad result. Okay, no. I'm gonna say store as global variable and then copy temp2. Okay, this is the bad result, and then we need a good result now. Okay, this is a good result. Bad again. Good. Good. Okay, this is good enough, I guess. Wait a minute. Wait. I didn't store all of the results. I stored one. Okay, I'm gonna start over. I'll collect the good result first. I'll zoom in just slightly more, so it's closer to. Oh, this is bad now. Oh, I'll collect the bad then. Okay, I'm gonna store 1 variable, 2 variable, 3 variable. And for all of them, I'm gonna do copy temp3, temp4, temp5. Copy. This was bad, so paste it in here into the bad result, and now I'm gonna zoom out just slightly. Okay, so do the same thing here. Store as global, store as global, store as global, and then I'm gonna copy temp6, temp7. 7, 10, 8. Store it here. Put it in this file. Bam. Now, let's see if we can sort out what's going on. Read in this. So the first one. Wait. Okay. Outer box is not super interesting actually. It's the my box and the B box map entries that are interesting. So the first one is going to be for this is the good one. First one is going to be for the main function. Okay, let's start from the bottom one. We already looked at the bottom one, so we're just going to look at the my box of the bottom one in both of these. Let's do a split again. There's already a split, so we're good here. Okay, look at the bottom one, collapse the outer box. We only care about the my box of the bottom one, comparing the good versus the bad. What just happened? Did Adam crash on me? Okay. The y value is extremely positive versus the good one. Now I'm gonna go one level up and compare the my box of the second level. Okay, the y value is also extremely large compared to the y value of the outer box. So now let's compare the first level. The first level actually didn't have a very discernible difference in the y value. Okay, so that's actually very instructive. So that means the problem began at level 2, which is the level where we're rendering this fib with n equals 7 box. It's this level here. That's the level where we started getting messed up y values, that the y value get super big compared to what it was before. And that must have happened because the output of the layout algorithm at the previous step, so at the first layer, gave you a result that was not good. And in particular, it would have been the fib7. It would have been here, yeah. Okay, so I'm going to open up the same thing on the right hand side, looking for fib7. Yes, here, okay, yeah, awesome. Okay, so there's the discrepancy. The algorithm, when it was laying out the lines of code in the main function, it laid out the fib7 function call. In the bad case, it gave it a really large y value. In the good case, it gave a slightly negative y value. We need to figure out why that happened. Now look at the neighboring value as well. So the y value before that one, the print text before the fib text was extremely large as well. So we just keep going up. And the good version, it was not extremely large. And then the y value for the main function, though, this is not that different. So although the height is extremely different. Interesting. Why is the height of this one so much greater than the height of that one? So look, that is quite interesting. Let me look at the outer box, what it's supposed to look like. So I have an outer container. There's these line numbers, and this is just fib7. So this is the outer. Yeah, it's just this first level, fib7, and there's some line numbers, and then there's 3 lines of code. Line 1 is just this text box. Line 3 we divided up into 3 text boxes, which are contained within a horizontal container. Line 3 is just the closing bracket. That's all it is. And this line, in particular, the def main one, this line, in the bad version, it got a really huge height, but in the good version, it has a relatively small height. The huge height is about 4 times as great as this one. Why did that happen? I don't know. What we could do is and then presumably this height affects the y value in the next line. Feels like it should. This is also got a very large height. Each of these lines have a very large height. Each of these text boxes have a very large height. So what we could do is simply write a script or write code to take this box and lay it out with this my box. Let me do that. Okay, that's a good way to debug this, I think. We are getting somewhere. Finally, I think. But you never know. Okay, so I'm gonna take these guys, paste them in. Oh god. Okay, so this is the bad case, I think. Yeah. Bad case. And I'm going to call the fit box function with bad case dot outer box and bad case dot my box and the code font. What was it now? I'm gonna split myself and use myself as a reference. Fitbox. That. TypeScript is not agreeing with me, but I don't feel like fighting it right now, so I'm just gonna cheat and say as any. Okay. All right. So I'm gonna look at this def main. So this should have a very large height. Yes, that's the very large height. That's a very large height, and presumably, if I give it a more reasonable viewport, I think the only difference between the good case and the bad case is what's in the my box. So maybe I should call good box, but give it the good box, then it should no longer have this huge height, which is 38,000 something, but instead it should have something, a height that's like around 9,000. And then we can sort of, after that, whoa! Am I right? Yes, I have a height that's about 9,000. And it actually, okay. That's actually pretty cool. Okay, anyway. So I'm gonna call this guy bad box. Okay, this is bad box, and we have a good box, and then we have an outer box. Okay, there's outer box, and so this change outer box, and can just flip the good box to the bad box if I want. And then we can go in and drill down to figure out what's going on here and deeper into the fitbox algorithm. Whew. Alright, so right now we have the good box. Okay, let's look at, I'm gonna do basically a bug sandwich now. I don't know if you know about the bug sandwich. I actually have documented the bug sandwich. It's a video. It's about 15 minutes long. It's on YouTube. I wonder if I search for bug sandwich on YouTube, will it show up? Google even. Oh god. No. No. Oh good god, really? Okay. Toby Ho, put my name in there. Okay, it's the, yeah, if you Google for bug sandwich followed by my name, then you'll find this video, the debug school one, not the host bakery, which that looks interesting too. This Melbourne bakery shop. Oh god, are they putting bugs in that? I don't want to know. So watch this one if you want more details about the bug sandwich, which I am currently doing. Because well, I'll give a little bit of background. So the point of the bug sandwich is you are trying to compare a working case and a non-working case and sort of sniff out the key difference between them that is making one of them work and the other one not work. So I found those. I found the good case and the bad case. And now what I need to do is go into the algorithm and see where they sort of deviated in the execution. So I might put in some console.log. So we're calling this and sort of track the output of the logs. We might also use the step debugger to step through it as well. Let's see. I'm gonna split it. So I'm gonna drill into this fitbox algorithm. With in particular, actually the layout algorithm, I would think, although I'm not sure. Well, I actually think it's yeah, let's go into the fitbox algorithm, actually. Okay. Because this fitbox algorithm uses this binary search technique, which could try the layout with a different font size. And I guess is trying to figure out what's the best font size to use. So a good question actually is, what font size did it end up choosing? Let me print that out. And then compare the answer in the good case versus the bad case. Currently we're testing, dang it, I lost that code. What the heck? Oh, I called it good box. Okay, currently we're testing good box, and the font size it chose is 9942. Okay, that's a suspiciously familiar number. So I guess for the bad box, it chose 33 something something. 38083 as the font size. Seriously? And okay. Why? Oh. I understand now. Okay. I understand now. I think. Gonna put out some output to verify my intuition. Let me think. I understand now. I understand. Okay, I can visualize the problem now. But I want to try to explain it as the best I can for anyone that might be watching this now or in the very distant future. Let me think. But let me print out some output to sort of give an intuition of what this algorithm is doing. So it's going to try different font sizes. So I'll say trying font size, and then if it all fit, then it'll do one thing. If all the text fit into the box, given that font size, it'll do one thing. Otherwise, it will do a different thing. Okay, that's freaking awesome. So it, oh my god. All right, so this started at font size of 5 and everything fit. And then tried 10 and then it's like everything still fits. I guess this is because the box is extremely large at this point. The box is yeah, that size. It's like 100,000 pixels wide. So if you try to fit the text with a small font size, it's gonna fit. But the algorithm tries to maximize the font size, maximize the text size to still be able to fit in the box. So it keeps doubling the font size that it tries. Until it doesn't fit anymore. And at the point at which it doesn't fit is that one, 1,240 pixels. It didn't fit. This is interesting. And then it drops it back down. It does a midpoint between the one that fit and the one that didn't fit, which is these two. It is the midpoint between those two, still didn't fit, and still didn't fit, and then finally this one fits. It tries to increase it again, and then decrease it again, and finally it's happy with this one. So this one fits. Okay. So that was the bad box. But for the good box, whew, for good box, 9942 is what it came up with. Then there's a radically different font size, so it's 4 times as small. Just due to a very small difference in the overall box size, we actually kind of got a very big difference in the font size that the algorithm ended up choosing. Let me contemplate this. Now that I understand what the problem is, let me think. If you can visualize this, let me try to visualize this. So in one case, so in both cases, like I mean, the good box and the bad box have roughly the same dimensions, right? 11, well, 114,000 ish. So, and it's a square, so it's same width and height in both dimensions. So there's a 114K and it's 114K here. In one of the cases, it's trying to fit the text. Well, it's trying to fit like something like 14, 15, 16 def main print fib 7. That's the text it's trying to fit into this box, and it's like, what is the largest font size I can use so that all of this text still fits in this box, but I wanted the font size to be as large as possible so we make maximum use of the real estate within this box. So in one case, it chose the font size of 9942. So 9942 is like it's like 10K. It's a roughly 10K. And 10K is about 1/10, a little less than 1/10 of this. So less than 1/10. I'll do 11. So so if we split this up into 10 and a half, maybe 2, 3. Oh, so the font size is roughly this, which actually makes sense. In the second case, it shows 38K as the font size. Why would it do that? That seems like too big to fit, actually. Is that right? Try the bad box again. I may need to go very shortly, so may not have time to get everything cleared and understood, but I'm gonna try to do it, wrap this up now. So 38K, yeah, 38K, I can't imagine how 38K can fit in here, honestly, because 38K is what percentage of this? 38K divided by 114. 114 is about a third each character is gonna take up a third of this box, so it's more like 140. So that seems wrong. I don't see how then that can be right. But like I said, I gotta go now. But this is definitely a very good lead. It's a kind of a positive ending for a very long, grueling session. Okay, so I'm gonna stop the stream now, and I'll see you later.